So we're looking at question 4 of this paper. So A, the function f and g are defined by f of x, and g is defined in that way. Find the function f of g and determine its domain. So we find the function f of g. This is question 4. A, f is given as the function 2x minus 1 over 3 plus x, where x is not equal to -3, and g of x is equal to 1 over 2 minus x, where x is not equal to 2. Find the function f of g and determine the domain. So f of g of x is the function f of g, meaning in f, where there is x, we put g over 3 plus g. So g is 1 over 2 minus x minus 1, 3 plus 1 over 2 minus x. On top, the common denominator is going to be 2 minus x. And then for the first one, we get 2 minus 1 multiplied by 2 minus x. For the denominator, the common denominator will be 2 minus x. And then we get 3, 2 minus x plus 1. You expand the top one, that is 2 minus 2, which is 0. And then negative times negative, we get positive x over 2 minus x over 6 minus 3x plus 1 over 2 minus x. That is equal to x over 2 minus x divided by 6 plus 1, that is 7, minus 3x over 2 minus x. This can be written as x over 2 minus x multiplied by 2 minus x over 7 minus 3x. So that this piece and this one goes, and then we have x over 7 minus 3x. Then find the domain. The domain of f of g is the domain x a real number such that you can start with the domain of g, the inside function. X is not equal to 2. It's given already in the question. And then for this one, you get 7 minus 3x, you get it to 0, and solve x. Divide by -3, divide by -3. So x is 7 over 3. So you say x is not equal to 7 over 3, but x, let's say it's a real number. So this is the domain.
So,
Hello.
So when finding the domain of the composite function, we are saying we find first the domain of f of x, then also find the domain of the composite function that we just found.
You find the domain of G, the inner function.
Oh, yes, sir.
And the domain of your answer.
Oh, okay. Yes, sir. I meant G, sorry.
Okay.
May you please go through
Prince.
Yeah, sorry, I wanted to ask, what if you just put the domain, the answer you found? Like after solving for the whole thing, then you write the domain of that one only. Would it be wrong?
It will be wrong because that thing there is also affected by G. Let's look at this.
Oh, okay.
Okay, so as I go through, bring up a statement about your question. So for you to get f of G, you get G and take it where there is f. In f, where there is x, you take the whole G. So here we are very,
why is x not equal to 2 part of the domain?
because if you place 2 in G, G will be undefined. And yet where there is x, you are taking G. So how do you take what is undefined?
So sir, if you say it like that, why don't you also put 3? -3, sorry.
No, -3 is for f. And not for G, which goes inside.
So why didn't you equate the x on top of 57 minus 3x to 0?
Okay, hold this. For you to get the f of G itself, you go to f, where there is x here. F is already telling us that don't let this x to be -3. Then we get G, okay? And bring G where there is x in f. So when you take G where there is x in f, here, there's x, there's x. We brought in G. But what is G? G is this thing here. And this thing is not defined when x is 2. So you know that this function, it is like this when x is not 2. Because if x is 2, the G that you are carrying, taking where there is x, you don't know what it is. It is undefined. If I ask you, give me the name of what you're having, you will say undefined. Undefined is not a name. It simply says, I don't know. Now you cannot take what you don't know where there is x. Now, because I've taken what I know, it means that x is not part of that game. X is equal to 2 is not part of the game. Now, G is 1 over 2 minus x. So you multiply 2 by 1 over 2 minus x minus 1 over 3 plus 1 over 2 minus x. Then these are fractions in the numerator and in the denominator. So you do the fraction thing for both pieces and then do the computation. When you reach this stage, this is a fraction on top of a fraction. The over part is just the same as division. So we have put the division sign. And then if it's rotate on the right, you can use the multiplication sign. Then you get x over 7 minus 3x. the domain of this function. Though 2 can work if you bring it here. If we said what is f of g of 2, it will be 2 over 7 minus 3 by 2. This is 2 over 7 minus 6, which is 2 over 1, which is 2. But we also know that we can solve this by looking at f of g of 2. So if we went this way, we need first to know what g of 2 is. Now g of 2 is 1 over 2 minus 2, which is 1 over 0, undefined. So as if you have to use this, you're going to have 2 multiplied by undefined. Immediately you do this, then you know that it's a no-go area. So both options must work. If one fails, then the function is not defined there. You must not negotiate with the function for it to be defined. It must be defined automatically and in general. Yeah, that piece we need it.
Sir,
Yeah?
I want to ask a question. Let's say if I made a mistake on terms of copying the question, I made an error. Are you going to give me some marks if I follow the correct step?
Every error is punishable.
Yeah, I know.
So they can be very, 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 very minimal thing. But then, yeah. Maybe you can give it one mark out of 7.
Seriously?
It's a wrong
Because where
question.
there's 3 plus x, I wrote 3x plus x. I don't know where I got that.
Don't you think that someone can deliberately give themselves a simple question which they are able to solve in the name of wrong copy?
Yeah.
Yeah, so okay, let's go to B.
No, sir, you've not answered my question. I asked him to say, why didn't you put the x on top of the fraction to 0 as well? For us to get the domain.
First, get the domain. You only do that if you're looking for the horizontal center, which does not affect the domain. You only do that for the horizontal assumption. And that does not affect the domain. It affects the range. That one affects the range.
Right.
Okay, so from B up to D, they are connected. Complex, complex, then real, rational. So let's log out and get back quickly so that in the whole 40 minutes you're able to finish this question.